That's fine. What? Alright, so lesson 5.6, analyzing polynomial functions. So before we get into any of the zeros or multiplicity, we are going to start by talking about relative maximums and minimums. You may also see these referred to as local max and minimums. So this is a point where the function's value is greatest within the interval of that point, or the least value in that interval. And this occurs when the function changes from increase to decrease, or decrease to increase. So they're called what we call peaks and valleys. So looking at this picture, let's talk a little bit about different types of maximums and minimums. So we also have what's called an absolute maximum and minimum, and this is the highest and lowest points on the entire function's graph. Now, not every graph will have an absolute max or min, some will not. So you can see here that this graph does not have an absolute minimum because it just approaches negative infinity in this direction, right? So there's no absolute lowest value because it just goes on forever in the lower direction. So, what are you looking for?
The pocket.
I don't have any extra copies.
Okay.
Yeah, that's geometry stuff. So basically, let's talk about these types of peaks and valleys. So basically, a relative max is anywhere we go from increase to decrease. As you can see, this is a relative maximum. This is a relative minimum, which is where we go from decrease to increase. You had an original copy of it, right? You did receive a copy?
No, because I wasn't here the first day.
You haven't had one? I can give you one if you haven't received one.
Yeah.
I just mean, like, I don't have extras if you lost it.
No, I was original the first time. Thank you.
So, then we have what's called an absolute maximum. And an absolute maximum is basically the highest value that the graph will ever take. And this could also refer to a minimum, the lowest value. Now, an absolute maximum is not only an absolute, it is also a relative. So every single absolute is always a relative, but not every relative is absolute. Does that make sense? So this is a relative max because it is not the tallest point, but it is a point from increase to decrease. Alright, so it's a change in increase to decrease, but it's not the tallest one, which makes it relative and not absolute. Does that make sense? Alright, so let's go ahead and talk a little bit about zeros and multiplicity. So, a zero is a point where the function intersects the x-axis. Very good, x-axis. I was on Zoom, hang on. There we go. The x-axis. A polynomial function of degree n can have at most n real zeros. So n just means any. A polynomial of, so if it's like degree 3, can have at most 3 real zeros. So the main idea here is a polynomial function, whatever the degree is how many zeros that function has. Even polynomial degree always has an even number of zeros, or none at all. And an odd polynomial, degree polynomial, has an odd number of zeros. So now we're going to talk about multiplicity. So this is a completely new concept to Algebra 2 that you don't really at all talk about in Algebra 1. So this is how many times a zero repeats itself. So what differentiates a graph that has the same zero occurring multiple times? Well, let me show you. So if we go to Desmos real quick, just to pull up an example. Have the graphing calculator out. And I'm going to type in y equals x minus 2. That's my first zero. So as you can see, we cross the x-axis once at 2, just like we expected. Now if that 0 occurs again, see how we still cross the x-axis at 2. But what has changed is the fact that it no longer goes through that value, through the x-axis. It actually bounces on it, okay? Now if I put in another of that same 0, it changes it again. It now goes through the x-axis, but it looks differently than when it went through it before, right? What's the difference from the first one we looked at?
No, it's a different
Cube.
It's cubic. It has a cubic shape. Good, exactly. That's exactly what I was looking for. See how the shape has changed? Okay? This is odd, so odd goes through. And now if I put in a fourth one, we're not going to look at this too much in this class, but now it goes back up again. Okay? And now it has that shape that's like a quadratic, but it's more flat. So the more times you add in a 0, the flatter and flatter it gets, and it switches from crossing to bouncing to crossing to bouncing. You cross when you're at an odd multiplicity, You bounce when you're at an even, okay? So, if the multiplicity is odd,
Miss Russell,
sure,
would it be the same if you put like an exponent next to it instead of retyping it out every time?
exactly, yep.
I was
Yep.
just checking.
No, 100%, yeah. That's how you see it a lot of the time. If the multiplicity is odd, then the graph crosses at 0. You'll see often that I use the word through instead, just because in the context of the sentence it usually makes more sense, but usually you'll see crosses. And then if the multiplicity is even, the graph bounces at the 0. So, the appearance, it's all about the appearance here. So, do you see right here on this graph, see this little section appears linear? Obviously it's not a linear function, but see how it looks linear in this little part right here?
Yeah.
So, its appearance is linear, which means that its multiplicity is 1. Okay, that's the most standard type that you get. The 0 occurs one time, it crosses once, okay? Now, the next one has an appearance of what type of graph we learned about in this class? Quadratic, right? So linear is over here. Then we have quadratic. And quadratics have how many zeros?
1 or 2.
2, which means a multiplicity of 2. Even multiplicities bounce at the x-axis. See how it doesn't cross the x-axis anymore? It's just bouncing on the x-axis? Because it's an even multiplicity. And the last type, I think Jonathan mentioned it earlier, it is cubic. So cubic has this appearance. It still crosses the x-axis, but it does so in a different manner than linear. You see the difference between linear and cubic? Okay. So you do have to be able to visually identify these 3 differences in this class. I won't really ask you for anything higher than that because it gets more and more complex, but these 3 are going to be ones that I think are obvious enough, right, to see. But yeah, it can get way more complicated than that. So, let's go ahead and look at number 1. I'm going to zoom out and stretch this thing out a little bit so we have a little more visibility here. Okay. Because I can't really zoom in and show you everything. So, first thing we're looking at is the end behavior. As you can see, it starts down and ends up, which means that it is
Positive, odd.
good. Odd, positive, or positive, odd. Everyone on board with how we identified that?
Yeah.
It's because it doesn't.
Oh, you were absent yesterday, right? Yeah. So basically the main idea is, you see how it starts down and ends up?
Yeah.
If they're going in opposite directions, it's odd. Going the same direction is even. Its leading coefficient is positive if it ends on an up note. Leading coefficient is a negative if it ends on a down. You'll get the hang of it though. Or, and then you can always watch yesterday's video too. So now we're going to talk about the degree. So we have to look for the number of
Turning points?
turning points. How many do we have here?
2.
3. Good. So the number of turning points are basically the number of hills and valleys in your graph. And then you take that amount and you add 1 to it, and that determines the degree of your polynomial. Yes?
Third.
Because you add 1 to the turning points.
You add 1 to the turning points, yeah, exactly. So end behavior basically is just determining if it starts down, that's a negative infinity. It ends up, it's a
Positive infinity.
positive infinity. Now we're going to look at the number of real zeros. So this is where it diverges a little bit from what you learned about yesterday, because this is a little more complex. So we have a 0 occurring here and here, right? But now we have to then determine the multiplicity of each of those zeros, how many times they occur. This one has a linear appearance, right?
Yes.
You all see that? So that multiplicity is
1.
1 multiplicity. This one here has what kind of appearance?
Quadratic.
Good. So its multiplicity is
2.
2. So see how this point doesn't cross the x-axis, but it bounces on it?
Yeah.
So therefore that multiplicity is 2. See how this one does cross?
Yep.
So multiplicity of 2 means that there are 2 zeros at that point. Okay? So that 0 occurs twice. Multiplicity of 3 means that multiplicity occurs, that 0 occurs 3 times. So how many real zeros do we actually have here?
2. And 3.
3. because remember, this one occurs once, this one occurs twice. So that's where this is where it's a little different than yesterday. We only ever dealt with zeros that occur once. So you do have to be able to look out and see if a zero occurs twice, because it looks different on the graph when it does. Okay? So,
That makes imaginary zero.
very good. So to recap, the number of zeros has to total up to add up to the degree of the polynomial. So we can determine the number of imaginary zeros by taking the degree minus the number of real zeros, which gives us our number of imaginary zeros. Okay. So the domain for any polynomial function.
Wait, how did you get 3 zeros?
So the reason
I know you already said it, but
that's okay. So the reason that we have 3 zeros is because this zero occurs once. This zero actually occurs twice because of its appearance. See how it doesn't cross the axis but it bounces? That means that that zero actually occurs twice.
okay.
Okay? Yeah, so the multiplicity determines how many times that zero occurs. Okay. So the domain of any polynomial function.
Negative infinity to positive infinity.
Very good. Now here's a little tip for you. If your polynomial is odd, the range is also going to be negative infinity to positive infinity. If it's even, that's where your range is a little bit different because it's going to have a max or a min. So if it's odd, range is the same. Okay? Now we're going to get into minimums and maximums, and these occur at the turning points. Okay? So first we'll talk about absolute max and absolute min. Now I'll just let you in on a secret. If it's odd, you're not going to have either one. Anyone know why?
Because it has to be even facing the same way.
Exactly, yeah. So the absolute max is none because it's just going off to positive infinity, right? And the minimum is the exact same situation. It's none because it's going to negative infinity down there. So for that reason, we don't have any absolutes. But do we have any relatives? We do. We have two relatives, right? We have a relative max and a relative min. The relative max, anyone know the coordinates of that? Negative 1, 1. Good. Everyone agree with that and understand how I found it? It's just like the little hills on the roller coaster. You see it?
And then 1, 0.
Good. Relative maxes are the tops of the hills. Relative mins are the valleys. Okay? Y-intercept occurs at what point?
What?
The y-intercept.
Oh.
Good. 0.5. 0, 0.5. So this is,
Wait, how'd you get 0.5?
it's just where we cross the y-axis.
Oh, you just like, it was no solution. You just like.
No, yeah, so I just like looked here and saw that it was at about 0.5. So this is the one that throws people off for some reason, so I do want to just make sure I'm clear about explaining this right here. So increase and decrease intervals. So every time you do an increase and decrease interval, I want you to think about it this way. You always get on the roller coaster on the left, okay, just like you read English left to right. So you get on the roller coaster over here, and you're riding on the roller coaster. So where are we going up? We're going up everywhere I'm going to highlight in the blue. So I'm just looking at the sections for which I'm going up on the ride. What happens in this middle section?
You go down.
I do go down, so I'm not going to include that in my increase interval. And then this middle section, I'm going down, right?
Yes.
Everyone see that?
Yes.
All right. So now that we've addressed it, let's go ahead and label it. So we're increasing on the blue. I try to color code to make it clear. Decreasing on the orange. Can everyone visually see why that is?
Yes.
Okay. So increase and decrease intervals. You always use x, okay? You never include y in any of those intervals, okay? You only look at the numbers on that x-axis. Pretend the y-axis isn't even there, okay? Only use x values. I say that because students always mix this up. So, increase intervals. Our graph is increasing on the x from negative infinity, because it's been increasing forever, up until it gets to the x value of
-2.
not -2, but
-1.
-1. Union, then it starts increasing again at what value? 1 until it gets to positive infinity. It increases forever at that point. There's only one little section of the graph that it decreases, and it decreases from what to what? From -1 to 1. Now, if we're talking about continuous functions, which we typically are in this class, your decrease and increase will pick up where the other one left off. Increases, then decreases, then increases. See how the decrease picks up in the middle where that one left off?
Yes.
That's always going to happen with a continuous function. Okay? So, everyone in understanding of this, and when you do increase, decrease intervals, you always use curved brackets, parentheses. You never use the square ones, ever, in these. Okay? Because there is the intermediate point where they change, doesn't count as either one. Alright, what did you think about the first one?
Pretty self-explanatory.
Okay, you ready to try another one?
Yeah.
So, this one starts down and ends down, right?
Yes.
Same direction means it is? Good, it's even and negative because it ends down. Negative means it ends down, positive means it ends up. Now we're going to look at the turning points. We have 1, 2, 3 turning points. Everyone see that? That's where we cross hills and valleys, where we change direction. Which means that the degree is? Fourth. Now we're just going to write out our end behavior. So since it's going down on both sides, negative infinity, negative infinity. Okay, that just means it's going down on both ends. Real zeros. What's the multiplicity of both of these zeros? 1. So there's just 2 simple zeros here, right?
Yes.
And that's because they both have a linear appearance to them. Does everyone see how it's just standard multiplicity of 1 zeros here? So if there are 2 real zeros and the degree is fourth, how many imaginary zeros must there be? 2. Because the total number of zeros has to add up to the degree of the polynomial. Make sense?
Yes.
Alright. The domain for every single polynomial function,
-infinity to positive infinity.
good, is always negative infinity to positive infinity. Now, because this is even, there is a discrepancy in the range. Now, the range does start from negative infinity, because range is bottom to top, or down to up. Remember? So it starts down at negative infinity, but does it go up forever?
No. It stops at -3.
It stops at,
It doesn't say
1, 2,
because
3, 4.
you can just count it. It's 1, 2, 3, 4. And that's actually a square bracket. So that's not really included on the way your notes are written, but you want to make that into a square bracket. Does everyone understand why the 4 is a square bracket?
because it's included.
Good, it's included, exactly. So now we're going to look at absolute value, or absolute values on the graph. What's the absolute maximum?
4.
Good, it is at 4. It's at -2, 4, right?
Yeah.
You're right, though, yeah. Sometimes it will just be asked in the terms of the y, but I just wrote the whole coordinate out. Is there an absolute minimum? No, because it's just going down to?
Negative infinity.
Good. Now remember, every single absolute max is first a relative max. So if you have an absolute max, you have to also write it on the relative line, because it still is a relative max as well as being an absolute. Now, do we have any other relative maximums?
It's
Yeah.
like
Yeah, it's kind of in the middle.
3.2.
3.5,
-2.
1, 2.
2.2 is the one.
Yeah, so it's 1, 2,
It's 2.5.
2.5, comma, -1.5, right? Does everyone see where I got that from?
Yeah.
Yeah, it's a little bit in the middle there, so it's hard to see. And do we have any relative minimums?
Yes.
What is it?
One negative
Yeah,
five.
1, -5.
Good. 1 comma -5. So remember, relative minimums are valleys, relative maximums are hills. Now, y-intercept.
-2.
Good. 0 comma -2. And then we're going to do our intervals. So, we're increasing. Yep. Increase here. We go down and we start increasing again here. So this is my increase. And my decrease occur here. So does everyone understand the color coding here?
Yes.
Okay.
No.
No?
What? No.
Okay. So, it's increasing from -infinity until we get to 1, 2, -2. Union, it starts increasing again at 1 and stops increasing at
1.5.
yeah, 1.5ish. 2.5.
Oh, then we gotta change
The first one?
relative max, cause we put 1.5.
But that was the y value and
You see the
y-intercept.
relative max?
Yeah.
Y
It says
value.
1.5. You gotta change it to 2.
Wait.
That's the Y value.
That's what I've been saying since the beginning.
No, I believe you. My brain's just processing it. Wait a minute. So the relative maximum is here at 2. Oh, 1, 2, 2.5.
Yeah.
That's right. Yeah, it's at 2.5. These are right. What are you guys talking about? You're confusing me. What's wrong? What do you think's wrong with it?
I was referring to the rule.
No, wait, do you guys still think there's something wrong? I see. Okay, I thought I was doing something wrong, and I was like, I don't see anything. Okay. No, because that could happen, but I just genuinely wasn't understanding it. Alright, so what do you guys think about the decrease intervals? Where are they?
2
Good. -2.
and 4.
-2 to right here, which is 1.
1.
Union. And then it picks up at 2.5.
-infinity.
Positive infinity. Yeah. Make sense? Those are always the hardest part.
I got that one.
Good. So there is one that is pretty wonky with the increase decrease, so we're gonna skip that one because it's number 4. The rest of number 4 is pretty easy, except the increase decrease are hard on this one because a lot of them occur at decimals. So we'll not do that one today. We'll just do. So what do you think about this so far? Are you in understanding of it?
Yeah.
Okay. So let's do number 3 then. It's easier than number 4, because number 4 is just pretty like. It's not hard. It's just like time consuming because it's a lot of decimals.
I was gonna say, can you do 4? But then I realized, like, you.
I can write it up. It's easier if I do it like in not teaching. Like I can always write the answer up if you want.
Is it decimal?
Yeah.
A lot of the increase decrease intervals occur at like a 0.75 on one of these. I did it last period, my first period. It's not impossible. Like you can do it. It's just there's a lot of decimals. That's why I just avoided it. So, this is odd positive, right?
Yeah.
Degree is 3. Turning points is 2.
Wait, shouldn't it be odd negative? It's up down.
No, so the negative always depends on what it's doing at the end of its lifespan. So it's going up at the end, which means it's
Oh,
positive.
I'm on number 4 right now.
Okay, well,
I'm so stupid.
that is right for number 4 though. You're right though about number 4. So the end behavior is down and then up. So yeah, you can see that 4 is odd negative if you're wondering.
Thank you. Dismissal.
You're welcome.
Okay.
How how many times do we cross the x-axis on number 3? Once, and what's the appearance of it?
Linear.
So it is just
One.
just a regular, simple one regular zero, which means yes, we have two imaginary zeros. Now another way to kind of check your work, imaginary zeros always come in even pairs. So like if you get an odd imaginary, you know that something else might be off about the graph, okay? So you might have like counted a zero wrong. The domain of any polynomial function is always negative infinity to positive infinity, and since it's odd, the range is also that, because it's going down up forever and up forever. Is there an absolute maximum? No, it just goes to positive infinity. And minimum also just goes to positive infinity. Is there a relative one? What is it? Negative 110. I think it's going by twos on that. 2,
Yeah.
4, 6, yeah.
1 and then 10.
Yep.
-1.
And the other one is 1, 4, right? The min? What's the y-intercept? It's not at 6. It's at 7, yeah. Does everyone see why it's at 7?
Yeah.
And then increase, decrease, so it's going up here. And it stops going up here. So it's increasing from negative infinity until it gets to negative 1. And then it picks back up at 1 to positive infinity. And then decrease from negative 1 to 1, right? Would everyone agree with that assessment? Okay. So for our sanity, we're going to skip number 4 and move on to 5. It's actually not that bad. It's just, like I said, it's just a lot of decimals. All right. So number 5 is really, really important. You do have a quiz coming up this week. I know you just had one, but this quiz is actually it's a short and easy quiz. It's not hard. And a lot of the questions are like almost the exact same type of questions you had on the last one. It's only 8 questions. So,
Can you move up a little bit, just for 1 second?
Well, 2 seconds.
so let's go ahead and start talking about this question number 5. So I'm just going to be highlighting these intervals so you can see them a little better, okay? So just so you can like visually identify them. And then we have an interval here. All right, so for number 5, you good with that one now?
Yeah.
So for number 5, does everyone understand why I highlighted what I did here?
Yeah.
Okay. So it says, what is the relative or local maximum on the interval -2 to -1? So what is the relative maximum in this interval? Of those choices, what do you think it is?
-1.4.
In the orange, what's the relative max? Maximum. So when they're
+37.
good.
How did
So,
you?
so when they're asking about the relative min or
Not
max,
37. 3.7.
3.7, yeah. So when they're asking about a relative min or max, you know how we usually write it as a coordinate? When they're asking about just a max or min like this, they just want to know the y-coordinate of it. You see that?
Oh.
So they're asking about the y. I will typically just ask you to put the point because it's more inclusive of all the information about it. But like when they ask specifically about a maximum, maximums occur on the y-axis because it's up and down, right? So make sure you're looking at the y value.
But the minimum is still the x-axis, or no?
So when they just specifically ask, and sometimes the question will ask you it will give you a coordinate, but if it doesn't provide you a coordinate and just a single number, you're going to base that on the y. Okay? For this. Because think about what a maximum and minimum is. It occurs at the highest point. So we're basing it on the y in our heads anyways. So between -1 and 1, what is the local minimum here? Good. And what would be the local maximum?
Maximum would be 1.4.
Positive 1.4.
Are we gonna do 6 or no?
Yeah, we have to do those. Alright. Those ones aren't that long though.
No, they're literally just putting in.
Is everyone good with number 5?
Yeah, that looks easy.
So now we're gonna do some sketches. So this is actually like something that you have to do a lot in like calc class and stuff. So I do want to get you a good start on this because I felt like I didn't really practice this much in Algebra 2, so I think it's a good thing to practice. So let's talk about a sketch. So when they say sketching polynomials, think of like what a sketch means. It means like a rough draft, right? So this isn't in the expectation that this graph is going to look like it would look if you put it in Desmos, okay? This is just a sketch. So you have the key features, you have the right direction, but all the hills and valleys don't necessarily have to be the proper height, okay? So it says an odd degree function with zeros at. So they tell us we have these zeros. So the first thing we're going to do is plot those zeros. It does have a lot of zeros. It's going to be a big polynomial. So when they don't specify a multiplicity, you assume the multiplicity is 1. Unless if they listed a 0 multiple times, like say they said -5 comma -5, that means the multiplicity of that 0 would be 2, right? It would occur twice, which would mean it would bounce at that point, right? So they tell us that the end behavior is an odd degree function that starts up and ends down, okay? So it's going to be like this: up, down, up, down, up, down. So like I said, it doesn't have to be perfect, it's just a sketch. So as long as it follows all of the proper instructions, then you're good to go. Now what I always suggest is just double checking everything. So I see that I have 1, 2, 3, 4 turning points. Is that in line with an odd degree function? This would be 5th degree, which is odd. So you can always check your valleys and hills and make sure that it defines an odd or even to double check your work. Okay? Does that make sense? Alright. So this one says a degree 4 function. So that means we're going to have 3 turning points, right? With a negative leading coefficient. If it, degree 4, is that even or odd? Even. Negative is going to be down and down. It's going to end down and start down. Does everyone see how I determined that? Okay. We have zeros at -1 and at 1. And then here's where they try to throw you off. Does anyone remember what a root is?
It's the same thing as a 0.
Exactly, it's the same thing. So they use different terminology. They'll say solutions, zeros, roots, x-intercepts. They all mean the same thing. They're just trying to make sure you know that. Yes?
So you would plot at -2 as well?
You would plot at -2 as well.
And that's a bouncy one, right?
It is a bouncy one. So at that one, it's not going to go through the axis, it's going to bounce on the axis. So I know that my graph has to start downward, okay? So basically my graph starts here, and it bounces here. So it's going to come back up, and then it's got to come back down. So it's ending downward like it's supposed to. And then I check and make sure that I have 3 turning points. You see that? Because I need 3 turning points for a 4th degree polynomial.
So you have to edit it for the y-intercept.
Oh, you're right. I forgot about that. Then we forgot the last thing. The y-intercept should be at 0, 4, so I don't know why I just got so excited about the other thing that I forgot. So yeah, this part should be a little higher here. It's okay. It's going to be okay. So yeah, that was my bad. Sorry. So how does everyone feel about sketching?
Pretty good. I like it.
You like it?